Hello and welcome. The purpose of this video is for you to be able to identify situations when integers can and cannot be divided, and to be able to explain why a number is rational. To do this, we're first going to define 4 different types of numbers. And we're going to start with whole numbers. The definition of whole numbers are numbers from 0 to infinity. So if we had to come up with some examples for whole numbers, that would be 0 or 15, my favorite number, or 1,111. Some non-examples would be -5, because -5 is less than 0. Another non-example would be 1 2/10, because this is a decimal, not a whole number. And a last example of a non-example would be 1/9, because 1/9 as a decimal is 0.1 repeating, and that would not be a whole number. Our next definition is integers, and integers are negative integers, 0, and positive integers. So some examples of this would be -123, 0, and 4. Some non-examples would be -3 and 4/10, because that is a decimal, not an integer. -2/3 would also be a non-example, because -2/3 can be written as the decimal -0.6 repeating, and that's a decimal, not an integer. Our next definition are rational numbers, and rational numbers are numbers that can be written as a quotient of 2 integers. And you're probably thinking, that's really confusing, and it is. So an easier way to think of this, remember, quotient in math means to divide. So if we're dividing 2 integers, that's the same thing as a fraction right here. So an example of a rational number would be -1 and 1/2. Well, right now it's not a quotient of 2 integers, but we can change it to an improper fraction by multiplying 2 times 1, which is 2, plus 1, which is 3. So this is the same thing as -3/2. Now it is a quotient of 2 integers, so it is a rational number. Another example would be 2 2/10. Right now it's written as a decimal. To write it as a mixed number, we would write it as 2 2/10. We can simplify that to 2 1/5. And finally, we can write that as a quotient of 2 integers by multiplying 5 times 2, which is 10, plus 1, which is 11. So that would be 11/5. A non-example would be the square root of 7. If you were to type in the square root of 7 on your calculator, it's going to change it to the decimal 2.6457, and we're going to put a ... because it will continue on and on and on. If you ever have a number that goes on forever, it cannot be written as a quotient of 2 integers. So it would be an example of an irrational number, which we'll talk about in a little bit. Another non-example would be pi, because pi is 3.14159, and it goes on and on and on. How many decimals of pi do you know? Finally, our last definition is irrational numbers. Irrational numbers are numbers that cannot be written as a fraction. So that would be these non-examples over here. So once again, pi is an irrational number, 3.14159. We're going to put a ... because it goes on forever and ever. It would never be able to be written as a fraction. Another non-example would be the golden ratio. And if you're wondering what that is, you should go ahead and look it up. As a decimal, the golden ratio goes on forever. Once again, 1.61803, and we're going to put another ... so it can never be written as a fraction because it does not terminate. Some non-examples would be all those rational numbers, integers, and whole numbers we talked about, because all of those can be written as fractions. So for instance, -4/5, that already is a quotient of 2 integers. It's a rational number. so it's a non-example. Or -5 and 25/100ths. We can simplify that to -5 and 1/4 by dividing the numerator and denominator by 25. And then we can change that to a quotient of two integers by multiplying 4 times 5, which is 20, plus 1, so 21/4. And remember it's negative, so -21/4. Okay, turn to the next page in your notes. So a big idea of this video is being able to explain why a number is rational. And to be able to do that, you have to know what a rational number is. So remember the definition of a rational number is a number that can be written as a quotient of two integers, also known as remember that's the same thing as a fraction, because quotient means to divide, and the numerator and denominator, you're dividing those two integers, which is a fraction. So here are some examples. 6 can be written as a quotient of two integers. It's the same thing as 6/1. 6 divided by 1 is still 6. So right here we're representing it as a quotient of two integers. -2. We can write -2 as -2/1, where now we have a quotient of two integers. Remember, with a fraction, you can either assign the negative to the numerator or you could assign the negative to the denominator. Either way, it would be -2. 0 and 75/100ths. Right now this is a decimal, but we can write it as a fraction, 75/100ths, and then we can simplify that fraction by dividing by 25, so it would be 3/4. It's a rational number because it's a quotient of two integers. The mixed number, -1 and 1/5, we can change that to an improper fraction by multiplying 5 times 1, which is 5, plus 1, which is 6. So as a quotient of two integers, it would be -6/5. And remember, you can write that with the negative on top with the 6, the numerator, or you can write that with -5 on the bottom with the denominator. And then -2 and 3/10. We can write that as a mixed number, -2 and 3/10, which then we can change to a quotient of two integers by multiplying 10 times 2, which is 20, plus 3, which is 23. So it would be -23/10. And finally, 3 and 7/8 can be written as a rational number. 8 times 3 is 24, plus 7 is 31. So this is the same thing as 31/8. The next section in your notes, you're going to be able to try some on your own. So go ahead and try the next section, pause the video, and then when you're done with the next 4 examples, unpause the video and see if you got it right. All right, let's see how you did. Drum roll, please. Yes, 21 can be written as a quotient of two integers, or a rational number, 21/1. The next example, -3 and 1/3, is a rational number because this mixed number can be written as a quotient of two integers, or improper fraction, -10/3. And I got that by multiplying 3 times 3, which is 9, plus 1, which is 10. -1 and 25/100ths is a rational number because it can be written as the mixed number -1 and 25/100ths, which simplifies to -1 and 1/4, which can then be written as a quotient of two integers, or improper fraction, -5/4, by multiplying the 4 times 1, which is 4, plus 1, which is 5. And finally, 14/0 cannot be written as a rational number because you can never have a denominator of 0. You cannot divide something into nothing. So hopefully you did well on that. If you missed some or you have some questions, make sure you come to class tomorrow with those questions of why you got certain examples wrong. Finally, let's turn to our last page of the notes. And on this page, we're going to talk about the types of numbers that could possibly be a little bit confusing to define as rational numbers or not. So the first example we're going to talk about is 0.6 repeating. Now, anything that repeats or terminates, another word for terminates is ends, is going to be a rational number because you're going to be able to write it as a fraction or quotient of two integers. 0.6 repeating can be written as the fraction 2/3. Negative 1.3 repeating can be written as the mixed number negative 1 1/3, which we can then turn into a quotient of two integers by multiplying 3 times 1, which is 3, plus 1, which is 4. So that's the same thing as negative 4/3. Those are examples of repeating numbers, which will always be rational. And then the next two examples are decimals that terminate or end. So 3 and 25/100ths, we can write that as the mixed number 3 and 1/4, which can then be turned into a quotient of two integers. 4 times 3 is 12, plus 1 is 13. So this is the same thing as 13/4. And 4 and 375,000ths, we can write that as a mixed number right here. And then we can simplify that to 4 and 3/8, which can then be turned into a quotient of two integers. 8 times 4 is 32, plus 3 is 35. So that's the same thing as 35/8. Remember from the first page of our notes, irrational numbers are numbers that go on forever and ever and ever. They cannot be written as a fraction. So examples of that would be pi. Anytime you see the ... that means it goes on forever. The square root of 3, if you were to type that into your calculator, you would get 1.7320, and it goes on and on and on. So that would be an irrational number. And then here's another example of a decimal with the ... showing that it never ends. So those will always be irrational numbers. So your final example in the notes are for you to circle the numbers that are rational. So go ahead and pause the video, and if they are rational, show how they're rational. And if they're irrational numbers, go ahead and show how they're irrational. Let's see how you did. Go ahead and look to see if you circled the same rational numbers that I did. I showed all my work for why they were irrational versus rational. So if you have any questions on this or you're still not understanding the concept, please come to class tomorrow with those questions and I will help you. Thank you so much for watching the video, and we will see you in class. Bye-bye.